about momentum, about collisions. Right, the diagram shows two particles P and Q on a slope, plane ABC. The masses are m, angle theta to horizontal, we have sine theta, and we have the length AB, the length BC. AB is smooth, BC is rough, the friction is 0.25. Particle P at rest from A, same instant Q at rest from B. from B, so they are both released at the same time. Verify the particle P reaches B 0.5 after it's released 3 meters per second. So for the first part, we have the mass m, which means the weight is mg. We can split this weight into w cos, w sine. We don't care about this, there's no friction anyway, just focus on this force down the slope. Sigma f equals ma. We can find the acceleration, which is g sine. Since we have the acceleration and we know that initially released from rest u equals 0, the distance is 0.75, we have a, we can find the time, we can find the velocity. To find the time, we use this formula. So just plug in, you find the time, which is proven 0.5 seconds, and to find the velocity, we use this formula and plug in the numbers, we get 3, so it's also proven. Now find the time it takes from the instant the two particles are released until they collide. So first of all, let's find the acceleration on the rough part of the slope. So when it's rough, now we're gonna need this W cos because we have friction. This normal reaction force is equal to the W cos, this is normal reaction, and the friction is mu times normal reaction, so the friction is mu mg cos. So the friction is going up the slope, and we have the weight component down the slope. So to find the acceleration, sigma f equals ma, we have w sine minus mu w cos, cancel out the m, we get the acceleration, plug in the numbers, we have the acceleration during the rough part of the slope. And in case you are wondering how do we find the cos, because we are only given the value of sine, well, we can find the cos using this triangle. Since we know the sine value is 0.6, which is 6/10, draw a triangle. Sine is opposite over hypotenuse. Use Pythagoras, we get the adjacent, so the cos is adjacent over hypotenuse 0.8. Okay, so that's how we get this 0.8. So all this trouble is only to find the acceleration during the rough part BC. So now remember, when the P reaches B, the speed is 3, and this happens in 0.5 seconds after it was released. So that means when the P reaches B, the Q has already gone some distance down the slope. So Q is 0.5 seconds ahead. So that means when P has moved, say 10 seconds, Q has moved 10.5 seconds then. So when the P reaches this part here, let's say it takes, now it's moving some distance from here, going down 10 seconds, the Q has gone from the point of release 10.5 seconds. Okay, so this is the key to find the answer here. So we're just gonna say the time for Q here, because this is from the instant released, so we're gonna use t as the time for Q to go when it's released, that's t. So that means the time for P to travel during the rough patch here is only t minus 0.5. So for for P we use t minus 0.5, for Q we use t, and the initial velocity of P is 3, initial velocity of Q is 0, and the acceleration is the same, which is 4 during the rough slope. So just open up the brackets and expand everything, and we cancel out things here, and 3t minus 2t is just t, and this is minus 1, so the t is 1. So it takes 1 seconds for p to catch up and collide with q here. Okay, so during the rough patch. Next part, the two particles coalesce when they collide. Coefficient of friction is still okay. Time taken for the combined particle reaches c. So the first step here, right before colliding, we know that for p the velocity is 3 and the acceleration during the rough patch is 4. We know the time is 0.5 because previously it takes 1 second to hit, so that means p is traveling 0.5 seconds during the rough patch. Okay, so the 1 second is from the smooth to b 0.5 and from b to collision 0.5. We are only using the time during the rough patch with this acceleration. So from here we can use v minus equals u plus at. We can find the velocity of p right before hitting q, and for q the initial velocity at this point released 0, acceleration during the rough slope 4, the time 1 second before it was hit by p, and we use this to find the velocity of q just before it got hit by p. So of course p is faster because it can catch up and hit q. So that's how we find the velocities before colliding. And now we also need the distance traveled. So when they collide, where is it? How far is it from b? So we use s equals ut plus 1/2 at squared. So if we are using these numbers for p, we're gonna get 2. And if we use these numbers for q, we also will get 2, of course, because when they collide, they travel the same distance. That's how they collide. Okay, so same thing, we can use p or q, we will get exactly the same distance. Now during the collision, we have the velocity of p, which is 5, velocity of q, which is 4, and they coalesce, they stick together, so total mass times the velocity after collision. Cancel out all the m, we have the v value. This is the velocity of the combined particle after collision. So now we know that this is the distance 2 meters from here, of course. So this is 2 meters. That is the distance traveled by p and q from b to the point of collision. That's 2 meters. And we know that the total length bc is 3.25, which means this distance is 1.25. So we need to find the time it takes for the combined particle to reach c. The speed of the combined particle is 4.5, so that's u. And we have the acceleration during the rough slope 4. We have the distance. We use this. We can find the time. So the time taken to reach c is 1/4 seconds. We cannot use negative time. Alright, I'll see you again next time.